what is industrial smog and how is it created? So industrial smog is created when smoke particulates and mixes with sulfur dioxide and creates this fog layer. And it tends to be lower to the ground. It's also composed of nitrogen oxides and ground level ozone. And the reason for its color is it contains a large amount of tiny aerosol particles that make it appear gray. Right here is the inversion layer, where the temperature inversion is the layer in atmosphere in which air temperature increases with height. We found that the primary chemicals are sulfur dioxide and nitrogen oxide.
I would throw in there, just for clarification, because there's this word aerosol particles, which is correct. Well, a broader term that's used often is particulate matter. That's what's in the textbook, and that's a word I'll be using a lot. But that's, everything else is right. So just don't forget particulate matter. Those are written down. So
where is it found? Industrial smog is mainly produced in factories. They're the primary creators of the issue. Mostly found in urban areas where factories burn fossil fuels. When they burn the coal, it creates smoke and sulfur dioxide and mix with the fog droplets and create a thick blanket of haze. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. VOCs, volatile organic compounds, are released from gasoline, paint, and many cleaning solvents. When sunlight hits these chemicals, they form airborne particles in ground level ozone or smog. That's sort of similar to, yeah.
So we heard about photochemical smog yesterday, and the main difference between the two smogs is kind of like where they're formed. Industrial smog usually forms in cool, humid environments, and then photochemical normally develops in warmer conditions, like in the summer. So the photochemical smog is kind of a brownish gray, and but like more brownish, and industrial is more gray.
why is it gray?
Because of the particulate matter.
Yeah.
Alright, so we provided a little history of industrial smog. Industrial smog became widely known during the 18th century and 19th century, and mostly during the Industrial Revolution. Coal started to become used widely on a large scale, and it produced a lot of smoke as it was used for combustion. So this resulted in a lot of health issues. An example is like New York City. There's a lot of health issues due to the new technologies that were being created during this time.
A major disaster involved with industrial smog was the Denora smog disaster in 1948. It was like a 4-day span. Killed about 20 individuals and 5,900 people were affected by the smog, which is 43% of that population, Denora. Worst air pollution disaster in U.S. history. So it started out with the impenetrable haze. First death occurred on the third day, fourth day. And then it sort of started to ramp up after that. People were told to evacuate, more people died. Yeah.
Okay. We heard about the Clean Air Act yesterday, but again, it's a federal law that regulates all sources of air emissions. So that's really helped regulate industrial smog everywhere. And then this is the scrubber, the picture, and that is what factories use to they have to now, like, restrict the chemicals that they're releasing into the atmosphere.
So, how do we solve this issue? This is, I want to say it's around the same list as we saw yesterday, but it's
From the same place.
Yeah, it's from the same source, which is National Geographic. But these are all things that we can do as an individual to solve the issue, which is drive cars with internal combustion engines, less walk, bike, carpool, and use public transportation. Take care of your cars, get regular car inspections, changing oil, and inflating tires to the proper level so you can improve gas mileage and also reduce emissions. Fuel up during the cooler hours of the day, like night or early morning. This prevents gas fumes from heating up and producing ozone. And lastly, avoid gas-powered yard equipment like lawnmowers. Use electric appliances instead.
So some of those effects, health effects that were discussed earlier, when inhaled, smog irritates our airways, increasing our risk of serious heart and lung diseases. These health risks are high, are why many cities monitor smog levels. Diminishes lung function, increased hospital admissions and emergency room visits for asthma, and increases in premature deaths. And then effects on the environment, as discussed yesterday. Ozone can damage plant cells and inhibit their growth, reducing the amount of carbon dioxide that they take in during photosynthesis. This is particularly noticeable for mountains and other beautiful vistas, such as national parks.
All right. But, hey, go back to that picture of Pennsylvania, just because it's really important.
What was that?
Well, I want to clarify something that's important. Yeah, one more. Yeah, that one. So notice the time period, the October one. And so what's really important here, and this, photochemical smog and industrial smog are very confusing because they're very similar, but they differ in one very specific way. What do you see in that photo? October 26th, noon. The lights are on because it's dark. So no, it's not happening at night. This is middle of the day. It says noon, right? This is noon. The particulate matter is the big difference here. In photochemical smog, we don't have particulate matter. In photochemical smog, we don't have sulfuric oxides in the same amount. Well, I guess we kind of do. The dominant pollutant in here is particulate matter and sulfur oxide. A little bit different compared to photochemical. Photochemical is NOx dominates, and then you create a tropospheric ozone. How is tropospheric ozone formed? Do you remember how it's formed? Does it come right out of the pipe?
No,
It requires what? How do we form tropospheric ozone in photochemical smog? We'll come to nitrogen here. Come to industrial here. How does photochemical smog get formed tropospheric ozone? B. You guys did that the other day?
Oh, with nitrogen when the sun.
The sun has to hit it. Where's the sun in that photo?
no sun.
So tropospheric ozone is very much not a big player in this, even though they said it was. It can sometimes show up. It's very unlikely if it's really cooking. Our gasoline has been cleaned up. We don't have sulfur oxides in gas as much. So it used to be a problem. Now it's not. This is mainly an industrial problem, right? So remember that key word, industrial, and then gray. It's also called gray smog because of all the particulate matter coming from all that debris from burning coal. Right? All right, so what's the primary pollutant? Don't tell them. What's the primary pollutant? And you tell them if they get it right.
No.
Primary pollutant for industrial smog.
Nitrous oxide.
Sulfur dioxide.
Which one's more primary than the other?
Sulfur.
Okay. Any other primary pollutants? You named two. Is there any other? One? Remember the photo? What's the other primary pollutant? Just three.
Smoke. Second.
We call it, but not just the smoke, but the stuff in the smoke.
Particulate
Particulate matter. Way different. If you inhale little particles of stuff you get in your lungs, it's hard to get it out. That's primary pollutants. NOx, SOx, particulate matter. The NOx is the least of the concern. It's sulfur dioxide, particulate matter, in orders of like dominance. And then, secondary pollutants. What's the secondary pollutant?
tropospheric ozone.
Yeah, rarely, but it could occur. Tropospheric ozone, only where the sun's hitting. Right? If the particulates are really bad, you're not going to have it. What are our sources? Can you name a point source for industrial? Factory of what?
Cool.
For a primary one. Wait, for a point source.
Yeah, so it has to be burning coal.
Yeah.
Point source is coal burn. Yeah. Do we burn coal often anywhere? Nope. In London, they burn them like pieces of wood in a fireplace. That's why they had a killer fog event that killed people. Up to 7,000 people died in the first 5 days of that event in London in 1952, the year this DNA was discovered. And then after that, associated respiratory disorders killed 12,000. Bad news. You know how to solve it? How do you solve it?
You'd have to, with your car, you can't like drive your car.
Well, if it's
that
mainly
much,
coal, my car doesn't use coal,
but also
so
like preventing,
done. How do you prevent the coal from polluting?
having some more regulating and changing what's going on inside.
What's
your
our law?
Clean Air Act.
It's like the answer for everything, right? It's gonna be on the quiz. Any questions for these folks? Awesome. Good. All right, now we got to get to the complicated one.